And then we'll get right back to our notes because we have got to make some progress there. Let's do one more, like is going to be on our quiz tomorrow. All right, how about this one? So, this is not in your notes. We're doing another practice problem to get warmed up here. And then we'll go back to our notes. So you might pretend for a moment that this is tomorrow and I've just handed you a piece of paper and it has this on it. So what's going through your head right now? Besides, I hate you, Mrs. Ford. No, you don't. What? What do you think? Do you see this over here? Okay, doesn't that mean that all this stuff has to cancel out somehow? So, if right now you cannot add any of those things and make them cancel. They're not like terms. But if they were all sines or all cosines, then maybe we could add them together and cancel some out, right? Do you have a mechanism for changing sine squareds into cosines? Yes, you do. Because you have memorized that sine squared plus cosine squared is 1, which means sine squared must be 1 minus cosine squared if I bring this over here. So I'll take that 1 minus cosine squared and put it right here. And then I'll put another one right here, but this one is times the cosine squared here. Now, at least, did I remember to turn this on? Okay. At least everything now is cosines. I still can't cancel yet, but let's clean it up a little bit. See what we got. We got 1 minus cosine squared plus, this is going to be a distribute. So that'll be cosine squared minus cosine to the 4th when you distribute. Does that by any chance equal 1?
Yeah.
These cancel, right? And these cancel, and the only thing you have left is the one that was out in the front. Okay? The hardest part, a lot of times, is just getting started. Do you understand kind of the logic behind how why we started this way? We had to get rid of stuff. So we made them all the same, like terms, so we could add them and cancel it. Okay, that's good. All right, so let's get back to our notes now. If we have time at the end of the period, we'll throw another one up here. So we got to get through a little bit more of our notes. The identities that we were using in 5.3, do you remember what those were called? They didn't write it down, but I told you the name of those is sum and difference. Those are the sum and difference identities. The ones we used in 5.3, sum and difference. SUM, we added and subtracted. The sign of U plus V. The sign of U minus V. We added and subtracted. The next group on the sheet, let me double check. No. Yes, right under the sum and difference identities are the ones called the double angle identities and the half angle identities. Do those names make sense? Right under your sum and difference, you've got sine, cosine, and tangent of 2 theta. Those are called the double angle. You're doubling the angle, 2 theta. And then under that, you have the half angle, theta over 2, the half angle identities. So today we're going to spend some time, and tomorrow, we're going to spend some time with the double and the halves. So, problem 5.4a, 1a, says cosine 15. We've already talked about one option for that. Does anybody remember from last time? How did we handle 15?
45 minus 30.
We thought of it as 45 minus 30. Okay? Now, that isn't what they want you to do here. What they want you to do here is think about it as half of 30. Isn't 15 half of 30? 30 is special. So now I'm going to do it in terms of half of a special angle. So look down your sheet. Find the formula. You do not have to memorize the half angle identities. Find the identity that does the cosine of half the angle. All right, what does it say? It's got a square root, big square root, and then it's 1 plus the cosine of 30 over 2, like that. Everybody looking at the one on the sheet and look at what I wrote, makes sense? 30 is my theta, or is theta the letter they used? Yeah. 30 is my theta. So 1 plus cosine 30 over 2. Well, guess what I need to do now? I need to find the cosine of 30. Well, I know how to do that. 30. You might have it memorized. If not, you can just draw it over here to the side. What's the cosine of 30? Root 3 over 2. Adjacent over hypotenuse, root 3 over 2. So you're going to have, maybe for the first time, you're going to have a radical under a radical. Don't panic. No big deal. It's perfectly okay. What's not okay is having all that fraction in there. That's not okay. That's called a complex fraction. We simplified one of these earlier. What would be a real quick way of getting rid of this fraction right here? Multiply everything by 2. Everything by 2. So now I have the square root of 2 plus, now these cancel, that's why you did it. So 2 plus root 3 over 4. Now, the square root of the numerator is just the square root of the numerator. There is nothing I can do to that. But what about the square root of the denominator? It's just 2. So there it is. There is the the cosine of 15 using the half angle identity. Now it doesn't look like what you got when you did the sum and difference. When you did 45 minus 30, it doesn't look the same, but if you typed it in on your calculator, it would be the same thing, just written in a different way. Did anybody notice the plus or minus in front of that formula? Did that confuse anybody? So here's the deal. We're finding the cosine of 15. Is that going to be a positive number or a negative number? Think about where 15 is. 15 will be positive. So that's why I didn't really use it. But if I were finding the cosine of some angle like, what's the next one? Oh no. If I were finding something like 195, then I would have to put the negative in front because that's a third quadrant angle and the cosine's negative there. You see, you never really escape your positives and negatives. You always have to pay attention to them. All right, let's do one more. Let's do the tangent of 67 and a half. Using, obviously, the half angle identity. There's really no other way to do 67 and a half. Is what divided by 2? 135? Is 135 one of my special angles, 135? Is that one of my special ones? Yes, because the reference angle is 45. So it's perfectly okay to rewrite 67 and a half as 135 over 2. Okay? Now, this is the angle, this is the problem right here. Don't look at the picture I drew, because the picture I drew is for this angle. Think about the original problem. Should the tangent of 67 be positive or negative? Positive, because 67 is in quadrant 1. That plus or minus is for the problem. And so it's going to be a positive radical. Now, I added, in my handwriting there, I added 1 minus cosine over 1 plus sine, because back when we had to memorize these things, when we, when the kids all had to memorize, it was easier to memorize that because it's sine over cosine. And if you look at the half angle formulas for sine and cosine, that makes sense. But if you want to use the other one, we can. Doesn't make a bit of difference. And that one says, I don't have it memorized. So that one's going to say we take the sine of 135 and we divide it by 1 plus the cosine of 135. If we use the typed formula instead of a handwritten formula. Is that okay with everybody? All right, let's look at our picture. 135, what's the sine of 135? Root 2 over 2. And what's the cosine of 135? Negative root 2 over 2. So I'm going to go ahead and make this a minus, because cosine is adjacent over hypotenuse. Uh-oh. Third time today, what have we got here? Complex fraction. What are we going to do? Multiply by 2 again. We're going to multiply by the common denominator, which happens to be 2 again. So we're going to multiply everything by 2. So that's going to cancel and that's going to cancel. So we end up with root 2 over 2 minus root 2. All right, then what? The conjugate, 2 plus root 2. So on top, I'm going to go ahead and distribute. So on top I get 2 root 2 plus 2. Does that make sense? And on the bottom, I get what? 4 minus 2. Check my multiplication. I think that's right. Is that okay? So that is 2 root 2 plus 2 over 2. Root 2 plus 1. Remember, when you cancel everything out, you got to have a 1. So it's root 2 plus 1. That would be the tangent of 67 and a half. Okay, does anybody have a question about that? Everybody understand why we're using 135? Because 135 divided by 2 is how you get 67 and a half. Okay. A couple more. And then we'll stop and do another review problem. Let's see if we can get through part 2. Look at your formulas, and they're all going to be in the double or half. So the ones that say 2 theta or the ones that say theta over 2, they're all going to be there. So I've got the square root of 1 minus cosine 47 over 2. Where do you see that formula? What is that the formula for? Sine something over 2. And the something is 47. So this is the formula for the sine of 23.5. That makes sense to everyone? That's easy enough if you have the formula sheet anyway. Here's a tricky one. Sine squared minus cosine squared. Okay, now look on your paper. Do you see anything that looks like that? You won't see exactly that, but do you see something that looks close to it? Cosine 2 theta? Except what? That is backwards, isn't it? Isn't that backwards? So we'll have to take a negative out, and then it would be cosine squared minus sine squared. That's on your sheet, and that's the formula for the cosine of 2 times an angle, and the angle is 87. So that's a formula for the cosine of 174, but it's backwards, so it's the opposite. It's the opposite of the cosine of 174 because the formula was backwards. And what about the last one here? Last one we'll do here. What was that? Where do you see something that looks like 2 tan, forget the number, 2 tan over 1 minus tan squared? That's the tangent of 2 times an angle, and the angle is 73. So this is the formula for the tangent of 146. All right, anybody have a question about those 3? All right, let's stop there with the notes. And let's do a couple more practice problems. Also, if you happen to have your homework packet, go to section, I think it's 5.5. Yeah, go to section 5.5 in the homework packet. And the very first problem, if you don't have your packet, that's fine. Just make a note of this so when we get to it, we're not there yet. But I tried to get clever and talk about triangle CHS, but then I didn't switch the other letters. So in problem number 1 on the 5.5 homework, the direction should say solve triangle ABC. Solve triangle ABC. Otherwise, you're going to get all confused because I don't have CHS in the problem. So ABC, triangle ABC, in the first problem in the 5.5 homework. Okay. All right, so let's pretend it's tomorrow. You've walked into class. I hand you a piece of paper, and it has this written on it. So what are you thinking? What are you noticing? Well, assuming you're going to work over there, are there any signs on this side? So wouldn't it be great if we could get rid of the signs? Is there a mechanism for changing sine squareds into cosines? There is. What do we know about sine squared? It's 1 minus cosine squared, right? So I'm simply going to change that into 1 minus cosine squared. Now make sure you put it in parentheses. You're changing your sine squared into 1 minus cosine squared. Make sure you put in parentheses, because see that negative right there? It's going to distribute. So we're going to have cosine squared minus 1 plus cosine squared. Is that going to give me what I wanted? Yep, because I've got 2 cosine squared minus 1. Anybody have a question about what I did there? Okay, getting started is the hard part. You understand my law? Oh, read.
I'm just kind of confused how sine changed the parentheses.
Okay, remember, I've already had this on the board. Sine squared plus cosine squared is 1. That is memorized. I want to know what sine squared is. So I'm going to move this cosine over here, and it's going to say sine squared equals 1 minus cosine squared. So it's that identity with things just rearranged in the equation. Just like if you have x plus y equals 4, you can say x equals 4 minus y. They're the same equation, just written in a different order. So then I have a substitution, and the point is I wanted to do that because if this is my goal, there's no signs in it. So somehow I have to get rid of the sign. And one way to do it, since it's squared, is to use that identity. Remember, these only work when you're squared. All right, let's do one more quick one. We'll make it real quick here. We'll make it an easy one. What about this? Okay, that is a really small one. What about that? What occurs to you on this one? Change cotangent. And what are you going to change cotangent into? Cosine over sine. So I've got cosine over sine. And then divided by 1 over sine. Now, that's another complex fraction, but this one would be easy to invert and multiply if you wanted to, but it's just as easy to multiply everything by sine. It's whichever strategy you want, but aren't we going to end up with just cosine when we do that? If you invert and multiply, you're going to have cosine over sine times sine over 1, which leaves you with cosine. Either way you do it. Okay, like I said, in the other class, I'll do different examples.